Okay, welcome back. All right, so just to summarize what we did towards the end of the previous part of this lecture here, we were talking about how the length of daylight at the equator was 12 hours on that day, and as we went farther north, the length of daylight was getting longer and longer, and in fact, you could get all the way towards north of the Arctic Circle on June 21st, and you would find that the length of daylight was 24 hours. The sun wasn't setting at all. In the same way, by the way, from the equator south, the days would be getting shorter and shorter, and the length of daylight, anyway, would be getting shorter and shorter. And in fact, once you got south of the Antarctic Circle, the sun wouldn't be coming up at all on that particular day. All right. Now, I'm actually going to put three little guys here on this globe here to illustrate something. So each of them is standing on the globe at their latitude there. And I want to illustrate here this one particular line where the yellow guy is standing. The yellow guy is the person for whom a beam of sunlight, which are those white lines coming from the right, in this case here, that guy standing there, he happens to be at 23.5 degrees north. That's a particular location. If you take out a globe or an atlas or something and you look on your map, they'll always have 23.5 degrees north labeled on the map because it is a location called the Tropic of Cancer. Cancer, because of the zodiac sign on June 21st, is in the sun is in the house of Cancer. And so that guy who's got the yellow guy standing there at 23.5 degrees north, he's got the sun directly overhead at noon that day. On the other hand, the two orange people that I have on the globe there, the sun is not directly overhead at noon. It will be as high as it's going to get at noon, but it will not be directly overhead on that day at noon. That makes 23.5 degrees north a special place on Earth on June 21st. It is a special place called the solar declination. Now, let's be clear about this here. Let's get a good dictionary definition of solar declination, because that's a term you're going to be seeing over and over again in this lecture here. The solar declination is the latitude where on a given day the sun will be directly overhead at noon. So the solar declination is a place, it's a latitude. And it is the place where on that given day the sun will be directly overhead at noon. Notice it depends on what day it is. In this case, on June 21st, the solar declination happens to be 23.5 degrees north, the so-called Tropic of Cancer. Now, that means that on June 21st, the June solstice, the sun's angles are highest, and therefore there is the least beam spreading at 23.5 degrees north. Wherever your solar declination is on any given day, that's where the sun angles are going to be highest. And therefore that is where we're going to have the least beam spreading. We're going to have very high values of short wave down. Because the sun is going to be very high in the sky, there's going to be very little beam spreading, and the sun is going to be warming the Earth up a great deal on that day because of very large values of short wave down. Well, 23.5 degrees north, that's in the northern hemisphere. It's June 21st. We're in the northern hemisphere summer. The days are long, the sun angles are high. This is the warm time of year in the northern hemisphere. Now, to illustrate how this works differently, let's switch 6 months later and move over to the other side of the globe here, to the other side of this map of the orbit of the Earth, and look at the December solstice. The December solstice happens on either December 21st or 22nd, depending on leap year and so on, as to which day exactly it happens. But here I have, again, illustrated from an older printing of the textbook, the configuration of the Earth and the tilt of its axis on December 21st. And what I want you to notice is, as the Earth has moved around its orbit, but kept its tilt of its axis pointing off towards the North Star, then now, in December, notice how the North Pole is tipped away from the Sun and the South Pole is tipped toward the Sun. And in fact, if you look at the North Pole there, if you can kind of, again, I couldn't quite figure out how to animate that globe, but if you animated that globe as it rotated around its axis, can you see how the North Pole would never have been in the Sun? The Sun doesn't come up at the North Pole on December 21st. And at the South Pole, the Sun never sets, okay? Because the Earth is tilted 23.5 degrees from the plane of the Earth's orbit. All right. Now, again, we can use our little trick for figuring out at least an estimate of the amount of hours that the sun will be up at any given location. If I just let the Earth, think about how it's rotating there. If I highlight a latitude line, in this case the equator, what I want to draw your attention to is notice that half of that line on the equator is on the night side of the Earth, and about half of the line is on the lit side of the Earth. And so we would estimate that along the equator on December 21st, there would be 12 hours of daylight and 12 hours of darkness. Hey, do you happen to remember on June 21st what was the story with the equator and length of daylight? For June 21st, there was 12 hours of daylight and 12 hours of darkness. I'm going to let you in on a little secret. At the equator, there's always 12 hours of daylight and 12 hours of darkness at the equator. Which is sometimes kind of people surprised. They think the days must be long because it's warm at the equator. No, the sun actually, rises at like 6 in the morning and sets at like 6 in the night all year round for locations at the equator. It's kind of a surprise for people often. Let's pick a higher latitude. This is about 40 degrees north, roughly the latitude of Omaha that I have highlighted here. Again, using our little trick here of noticing that about 2/3 of the line is on the night side of the Earth and about 1/3 of the line is on the daylight side of the Earth, we can estimate that at about 40 degrees north, we have about 16 hours, or 2/3 of the day, of darkness and about 8 hours, or 1/3 of the day, of daylight at that latitude here. Again, it's just an estimate. There are ways certainly to do it, and come up with numbers, accurate to the second, but that's not our point here. We're just estimating. And in fact, notice if I picked a high latitude, like someplace north of the Arctic Circle, maybe that's about 80 degrees north or something, you can see how the entirety of that line is on the dark side of the Earth, and none of that line is on the lit side of the Earth. And so along that latitude on December 21st, there will be no hours of daylight and 24 hours of darkness. So our little technique here has shown that the length of daylight at the equator was like 12 hours, but the farther north we went, the shorter the length of daylight went. And in fact, we could have applied the same technique in the southern hemisphere and found that the farther south we got of the equator, the length of daylight was getting longer and longer until you got south of the Antarctic Circle, where we would be seeing that the length of daylight was 24 hours on that day. Cool. Now, once again, let's take that idea and we're going to put 3 little guys on the globe here. And those little white lines that are sort of coming in onto the top of their head are showing the rays of the sunlight here. And on this particular day, this December solstice, December 21st and 22nd, the yellow guy is the guy who the rays of sunlight are coming in directly from above right onto his head. The sun angle is 90 degrees there. So that location where that yellow guy is happens to be a very particular latitude. It's 23.5 degrees south, which is known as the Tropic of Capricorn. Again, Capricorn, because December 21st is in the zodiac, the sun is in the house of Capricorn or whatever. So that's just a term from geography. Meteorologists would never have come up with a stupid term like that. So if you are at 23.5 degrees south on that particular day, you will have at noon the sun directly overhead. You're the only places on Earth where only places along 23.5 degrees south on December 21st will have the sun directly overhead at noon. I mean, at any other place, like where those 2 orange guys are standing, yes, the sun will be low at sunrise and get higher and higher over the course of the day until noon, but it won't be directly overhead. It'll be high, but it won't be directly overhead. So at this location here, then 23.5 degrees south, remember, has that name. It is the solar declination. On December 21st, the solar declination, remember solar declination is a latitude, solar declination is 23.5 degrees south on December 21st. So on December 21st, the sun angle is highest and the amount of beam spreading is least at 23.5 degrees south. Well, wait a minute. 23.5 degrees south, that's in the southern hemisphere. In December, hey, that's their summer. Well, that makes sense. This is northern hemisphere winter. The sun angles are low, the length of daylight is short. And southern hemisphere, the days are long and the sun angles are high. No wonder it's warm in December in the southern hemisphere. No wonder it's cold in the northern hemisphere in December. That's pretty slick. See how this idea of the solar declination, this latitude where on a particular day the sun is directly overhead, this idea of the solar declination is pretty powerful. Now, as it happens, the farthest north the solar declination ever gets over the course of the year is the Tropic of Cancer, 23.5 degrees north. And as it happens, the farthest south the solar declination can ever get is the Tropic of Capricorn, which is 23.5 degrees south. So most of the time, the solar declination is in between 23.5 degrees north and 23.5 degrees south. And you know what we call that part of the world? The tropics. Oh! See, the tropics, one way to define what we mean by the tropics is, they're the places where the sun can be directly overhead. Okay, outside of 23.5 degrees south and 23.5 degrees north, the sun is never directly overhead. Omaha's at 40 degrees north. The sun is never directly overhead in Omaha. We'll start figuring out ways to figure out how high the sun can get in Omaha, but it's never directly overhead. Now, just to quickly illustrate here, I don't want to bog down too much on it, but there's 2 more days you should be interested in, the March equinox and the September equinox. March equinox happens approximately March 21st and 22nd, depending on leap year. On that day, the solar declination is actually on the equator itself. So locations at the equator are the places where at noon the sun is directly overhead. It's called the equinox because equal night, equinox for like night. And it's because every place on Earth has a length of daylight of 12 hours and a length of darkness of 12 hours, regardless of what latitude you're at. The same is true of September. The September equinox happens on September 21st or 22nd, and it is the day in which the sun is directly overhead at the equator again, and again, so the solar declination is at the equator again, and all locations on the Earth have 12 hours of daylight and 12 hours of darkness. Now, so this idea of the solar declination is hugely powerful, and it's easy to remember what the solar declination is on the 2 solstices and the 2 equinoxes. Okay, memorize. I mean, on the December solstice, it's on December. It's 23.5 to south. On the March equinox and the September equinox, it's at the equator. The solar declination is at 23.5 degrees north on the June solstice. Okay, ta-da! You've memorized them. Okay, but what about any other given day of the year? Well, that's where a particular diagram comes in handy. It's called the analemma. Now, I'll make analemmas available to you as a handout on Blue Line, and anytime on like a quiz or on the homework or whatever, I also provide you an analemma so you can figure these kind of problems out. But the analemma is a type of chart that is used to determine the solar declination on any given day of the year. It's sort of a calendar, and if you kind of look at it closely there, you can see how there's like dates along the little kind of figure 8 shape there. If you follow around like those blue arrows do, you can find any given day of the year. And so if you trace around there along that little calendar there, along that figure 8 shape, you find a particular day. I just happen to have highlighted on this here, May 15th. And once you find the day, you go over to the left-hand side there, and you can read off what the solar declination is. In this case, it is about 18.5 to 19 degrees north. This particular analemma that I scanned here on this diagram here is a little bit tricky here because the N for north is just that little thing right above the number 24 right there. But when you work with the analemma, you'll see how it's labeled like that. There's the equator, and then the top half of the diagram is the northern hemisphere, the bottom half of the diagram is the southern hemisphere. It's just this particular one was a little bit harder to read there. So like in this case, you could find on May 15th, the solar declination is about 18.5 degrees north, and you could read off any given day of the year and find its estimate of the solar declination, the latitude where the sun is directly overhead. Again, there's ways mathematically to do this. I think in a little, box on their page or whatever, you actually have a mathematical, in your book, you have a mathematical way of figuring out the solar declination. There might even be, in the ATS 114 lab, there might be a problem or two where you use math to come up with an estimate of it, but let's not get bogged down in that. If you need to know that, your TAs will be glad to help you explain that in the lab. Now, before we actually go and solve more problems involving the analemma and the solar declination, let's answer a couple quick more questions here. Question 3. On July 4th in Omaha, the length of daylight will be blank 12 hours. Less than, more than, or exactly. Think about what time of year that is and where the sun angles. Yeah, think through this here. How are we going to figure out on July 4th how will there be more or less than 12 hours of sunlight, or exactly, in Omaha? All right, make a choice for one of those 3 options and get a little feedback before you move on to question 4.